Hi, in this video I'm going to do a code walkthrough of the toy app, the burger ordering app that uses Ai Struct to convert natural language into structured data. If you haven't seen the app in action, I recommend checking it out. The code that we're going to walk through today is on GitHub and the app is running at Heroku, and I'll put both of those links in the video description. So before we get into the code, just to familiarize you with the input and output that we're going to be talking about, this is the text input. In this case, it's a burger order. That text gets sent to Ai Struct. Ai Struct returns this JSON output of all of the entities. And then what we're also going to look at today is the post-processing that turns the JSON into an actual order. So let's get into the code. It's a Ruby on Rails application, but the code is clear enough that I think most people will understand what's going on. So that page we were just looking at is here. The text just gets captured. It gets captured using JavaScript. So if I jump over to the JavaScript file, in this particular case I'm using stimulus.js, but any, obviously, JavaScript library can do this. I'm using WebKit speech recognition, which is supported by Chrome, and so the code is almost nothing. There's a function here to start the capture, there's a function to stop the capture, and then when the capture ends, the transcript is added to the text area on the form. And then when the user submits it, the processing is done on the server side. So Ai Struct doesn't support the JavaScript being used to call the API. It's too hard to secure the API keys, so please do it server side. So let's jump over to what that looks like. Okay. So when we create the order, there's really only 3 steps: saving the order, converting that order to JSON, and then post-processing the order. Again, all this is happening server-side. So let's look at converting to JSON. Now this code here is the entirety of the interaction with Ai Struct. There's no plugins or additional libraries required, just whatever language you have that supports making a HTTP request will do the job. So we get our API key, we've got our API endpoint, it's a post request, we send the text, we send the template that's been pre-configured in Ai Struct, and there's another video to show you how to set up the template. And then we pick the mode, so that can be speed, balanced, or accuracy. Depending on your requirements, I recommend balanced for most use cases, where we send the request, we get our response, and we save it. That's it. So everything from here on is about post-processing. So what we're doing now is getting everything from this JSON response into this structured order. So let's go back to the code. Scroll up to the top. So basically there's three steps to processing the order. There's matching the entities that you get back from Ai Struct to items that are actually in your database. Once you've done that, it's creating the relationships between those items, and then finally filling in for any missing default information that you might need. So for example, in a burger order, as part of a meal, if the user doesn't specify any fries or drinks, we need to assume that fries and drinks are included in meals and add those items separately. But first step, let's just find the closest match. So what I've done here is hard-coded the types. Obviously, you wouldn't do that in a production app. And I've also hard-coded the types that have a size property, and then the sizes of small, medium, and large. And I've set a threshold for matching, and we'll talk a little bit about matching in a second. So first step is pull the entities. as a JSON object. And then we're going to cycle through the entities and find the closest match based on the type that's provided in Ai Struct and the types that are in our array from up here and the threshold. So let's jump down to find closest match. All we're doing is we're using the Levenstein approach for finding the closest object from a list. And that goes, so we're going to cycle through each of our potential candidates, find the minimum value based on the target. And then once we've done that, as long as we're above our threshold, we return the item. If we exceed our threshold, we return nil. So if the user asks for a burger, but they want to add a unicorn, then that won't match anything in our list and return nil. And what we need to then do is tell the user that we don't sell unicorns. So if we go back up to where we were before, now we do have to set a couple initial defaults, particularly if the user asks for a meal. They might not know, they might not say what size meal. So in this particular case, I've assumed medium. And if they say a drink or fries, but don't specify a size, I've just assumed small, but we can adjust that later if it ends up being part of a meal. So now that I've got the type and the size and the name, we go through and pull all items in our database that meet the size and type requirements. And then we go through and use our same approach again for finding the closest item in our database that has that property name. And if there's nil, that's where we put those items aside in a field called missing, and we can tell the user at the end, sorry, we couldn't match these items. At the end of all of that, what we end up with is a new entry into a results array, which contains the Ai Struct ID, the ID of the matching item, the category of the matching item, the name of the matching item, the size of the matching item, and we also retain the array of related to items. Now that's quite important and it's probably worth emphasizing. If I go back to the data and just pick out one of these items here in the JSON, you can see this burger, that's the king burger that was requested, is related to ID number 2. So this ID is set by Ai Struct, and ID 2 is the matching meal. Now, Ai Struct supports many-to-many relationships, so that's why the related to is an array. You might have, depending on your use case, different things related in different ways. And then what we need to do now is create this related to structure. So a meal has a burger has an addition, a burger has a subtraction. So the next item here is the addition, and that's related to 3, which is the burger. So that's the next step that we're going to go through now. So firstly, we need to create a list of the meals. So we just iterate through the results array and pull out the meals into their own separate array, which gives them and then what we want to do is going through all of the results. If it's not an addition, subtraction, or meal, this is where we want to create the selection to add that to the order. Now, as we're going through for each of the meals, we do want to know whether they have a burger and whether they have a side and have a drink. So this is all about validating the request from the user so that they're not ordering 3 burgers in a meal, or they're not ordering 6 sides, all as part of a meal. We're working on the assumption that a meal is simply a burger plus a side plus a drink. And then we create those selections. And in the process, we're also pulling out an array of burgers, because what we want to do then is we want to add the additions and subtractions as related to each of the burgers. So there's that hierarchy of meals have burgers, sides, and drinks, and then burgers have additions and subtractions. And so those get recorded as modifications, which we then create. So that's translating the data that has been provided, or the request that's been provided by the user, to the literal items that Ai Struct has returned. But now there's some missing items that we need to fill in. And this is very, very use case specific because we're ordering burgers in meals. And so what we're doing here is going through each of the meals and just validating that medium-sized meals should have at least medium sides. And so if they haven't specified a size for a drink, but they've ordered a large meal, then we need to upgrade the drink to a large. And then this last step here is to add many missing implied items. So again, if the user didn't specify that they wanted drinks and fries, we need to add those in to each of the meals. They might have said they wanted a particular drink, so if that's the case, that would be added, but we need to add some fries. If they've added multiple sides, it's not represented here, but you would have to add some additional code to remove those additional items from the meal and make them as separate items. Obviously, Ai Struct isn't going to know that you can't have 6 drinks as part of a meal if that's what the user asked for. So again, with natural language design, most of the work is on the developer to do the post-processing to make what the customer has requested fit the structured data validation requirements. So hopefully that's been useful. Again, this code is online at GitHub and the app is live at the link below. So visit ai-struct.com to sign up for free and start experimenting. We'd love to get your feedback.